And welcome. My name is Shannon Kemp, and I am the Executive Editor for Dataversity. We would like to thank you for joining today's Dataversity webinar, Data Architecture Requirements, this year's May edition in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now let me give the floor to Megan Jacobs, the webinar organizer from Data Blueprint, to introduce our speaker and today's webinar. Megan, hello.
Hi, thanks, Shannon. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are pleased that you found the time to join us for today's webinar on data architecture requirements. As always, a big thank you goes out to Shannon and Dataversity for hosting us. We'll get started in just a few moments after I let you know about some housekeeping items and introduce your presenter. We have 1 hour for the presentation, followed by 30 minutes of Q&A. We'll try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. To answer the top 2 most commonly asked questions, yes, you will receive an email with links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter, Facebook, and LinkedIn. We set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. We'll keep an eye on the Twitter feed, and we'll include answers to those questions in our post-session email. Now, let me introduce you to our presenter. Peter Aiken is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and 8 books. The most recent is Monetizing Data Management. Peter has experience with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. He often appears at conferences and is constantly traveling. So Peter, where are you headed now?
Hey, Megan. Tonight I'm going to go visit our local AITP chapter and give them a talk on big data, and tomorrow I'm headed out to Kansas City to talk to the DAMA chapter out at Kansas City. Looking forward to an all-day session on information architecture development out there. So welcome, everybody. It's good to have you with us today. Again, joint presentation for everybody. The focus that we're going to look at today is really designed to help many of you who are probably already good at data information architecture sort of broaden the uses of this. If we understand all these various uses that we're going to try to do with it, it'll give you an idea that it's not just a destination, it's actually part of the journey as you go through here. Again, we always get some good questions on this one, so I'm going to start off by talking first of all about the context that we always do, which is in the context of data management, DAMA, and the DIMBOK CDMP questions, because people are generally not familiar with those. Then we'll dive in and look at what is a data and information architecture, why is it important, and talk about the concept of leverage in particular as an engineering concept. And we'll finish up with 3 examples looking at a software package implementation context, a donation center processing, and a text mining analytics sort of example. And again, as always, we'll look forward to your questions when we get back around to the top of the hour here. So let's get started. I'd like to introduce data management by talking about Maslow's hierarchy of needs. Most people remember Maslow from high school, and the basics of his theory were that if the bottom level is not supported here, it's going to be hard to build the next levels on top of it. Again, a very easy way to think of this is if your food, clothing, and shelter needs and they are unmet, then it's unlikely you're going to be doing any self-actualization activities when you go home afterwards, whether it's singing with your band or playing musical instrument, writing or reading poetry, whatever it is. And for a number of reasons, data management falls into this practice area very, very nicely. I like to call the things in the golden triangle that I'm showing you here, and these are things like master data management, mining, big data analytics, warehousing, service-oriented architectures. These are really self-actualizing or advanced data management practices, but most people are really unaware that that's just the tip of the iceberg when it comes to data. And if you understand data and how it works, you know that there are some fundamental data management practices that you have to put in place. I've labeled them out here on the chart. We're going to show another chart in just a second that'll get into them in a little bit more detail. But the key to understanding this foundation is to know that the 5 practice areas that I'm showing you in the blue are linked by what I call a weak link in the chain method. That is to say, the chain is only as strong as the weakest link. So you could be good in 4 out of these 5 areas, but having one of them be deficient is going to drag down the overall quality of your data management program. And most organizations say, well, I understand that, but can I go do the stuff in the golden triangle because I like it, it's fun, it's more useful for us? And the answer is yes, you can go straight to the things that are in the golden triangle, but then your results will take longer, they will cost more, they will deliver less, and they will present greater risk to the organization than if instead you follow a crawl, walk, and run your way to the top of the organizational chart here, going first from the blue to the golden practices that are in place. A more detailed version of those 5 areas that I showed in the blue on the previous slide is this organizational data management practices chart. Again, it's too complicated. We're not going to go through it here. Those of you that have seen me talk know that we could spend literally hours working on it. But I'll simplify the diagram for those of you that are new to this particular series. The first one is called data program coordination, and that's all about managing our data coherently, trying to get us on the same page. What you have most likely in your organizations is that there are a lot of really good people trying really hard, and individually they can accomplish a lot, and that's how your organization is running now. But think what could happen if we trained them on the same methods and got them focused on the same goals. Then it becomes a very, very powerful lever in order to move data management practices. Second area is organizational data integration. This is the idea that we do share data across boundaries, whether it's from one application program to another application program, whether it's between our marketing department and our manufacturing department, or whether it's between our organization and our business partners that we do. We share data across boundaries, and we need to understand what data is moving across these boundaries and manage it efficiently. Similarly, we need a concept of stewardship, which is the idea of assigning responsibilities for data. If it's everybody's responsibility, nobody's going to touch it. The minute it says, Peter, your next raise depends on X, Y, or Z relative to this, then that is where we're going to start paying attention. So stewardship is about making it personal. Data development, our fourth area then, is to engineer data delivery systems, and for a number of reasons, we've been teaching our really smart people who are going to college and universities that the answer to all these questions is the relational database management system. There are some pockets of big data technologies that are being taught now, but for the vast majority of people, they learn about this in college and university from these books that are written on it that focus in on relationships. And relational is a fine model to work with, but there are others out there that aren't even exposed to them, so it's very much a case of people don't know what they don't know. Our fifth area then is the data support operations area, and the goal here is to maintain data availability. Just like a car, you need to go out and tune your data systems on a regular basis in order to come up with these ideas. So these are the 5 data management functions that we show. And just a quick little aside on all that, we want to make sure that absolutely everybody is focused in on the goal, which is to try and become certified through our DMBOK and CDMP certification process. I've put some links on the page here for you if you want to learn more about it. There are about 1,800 people worldwide that have passed this designation. We'd love to get you into that particular group. So that's our context here. Now let's look and talk about what is a data and information architecture. And the slide that I'm showing you here, this is a Wordle of all the slides that are in this thing. So it's how many times the word appears and what sort of arrangement. In other words, this is one way of looking quickly at the focus of what the presentation is going to be. It's useful to some degree. Younger people tend to like this approach more than us old graybeards that are involved in this. Another way people are exposed to information data architectures, they end up seeing these big charts. We call them wall charts that get up on the wall and people look at them, but they don't really know what they're trying to do about this. Now, we model data. We put it in a formal notation so that we can get a shared understanding between the IT and the business, because if we have disagreements, we have, if we have agreement on it, then we have good communication that's involved, and we'll see a couple examples of that coming up. This data exchange process, however, that occurs in most organizations is highly automated, so it's even more critical to engineer the solid foundations that need to be put there in place. So if the modeling characteristics change course, over the time of the analysis. Different models with different objectives may present very different analytical problems as we look at them. I like to incorporate a practice that Clive Finkelstein showed me early on, which is that we need to incorporate motivation or purpose statements in the modeling. It's fine to define something, but if you tell somebody why they are capturing that information as in a purpose statement, it's a much more powerful indicator of what the true requirements that the organization is working with are going through in this. The use of the modeling is more important than any specific method. The models are living documents, and the models must have a modern access way of getting at them, a search, a way of incorporating taxonomies and ontologies in there as well. The key, of course, is that there's no point in making a model if you're not trying to solve the problem, a particular problem. So models tend to be downward facing. They're looking at detail. Architectures, on the other hand, tend to be more abstract, the higher level of abstraction, and they really focus on integration. So in the past, we've had architecture that's attempted to get a perfect understanding. We now realize that it's not timely and it's certainly not feasible, but instead what we need to do is focus on the arrangement of the architectural frameworks, the architectural components that are governed by a framework in here. This gives us more immediate utility in there. So the dim box shows that this data management, architecture management practice area has a series of inputs, activities, and outputs. Again, I'm not going to go through this diagram with you. Much of this is reference material for you, but there's an entire chapter in the dim box that shows about these things. Now, the key for it is that architecture is both a process and a product, and that's an unfortunate construct that we use here in English in order to do that, but that it does describe things from a macro level. Most people today in IT understand architecture applies to the arrangement and the set of components that you're putting together in order to actually make a system. The architectures are symbolic in representation, and they also represent both the structure, the use, and more importantly, the reuse of resources that we're putting out there. The common components are represented using standard notations, and they're detailed enough to permit both a business analyst and a technical personnel to read the same model and come away with a shared understanding of it. And this understanding, when we say understanding in architecture, it means it's been documented and articulated as a digital blueprint that illustrates the commonalities and the interconnections among the architectural components. And ideally, again, this understanding is shared by systems and humans, although I'll give you one example that you've seen this smiling face up on lots and lots of things. It turns out that the healthcare debacle that occurred last October when the new healthcare system went online was problematic for a number of reasons. First of all, there were 55 contractors, so it was hard for anybody to gain a picture. Now, when I say contractors, this wasn't 55 people that were involved. There were 55 companies involved in this particular stew. And Jim Johnson, who's the chair of the Standish Group, made a great comment. He said that anybody who's written this live code can't be even surprised, mildly surprised that it didn't work right out of the gate. The real news should have been that it actually got it to work at all, especially after it had been cobbled together in the way it was. But I dug a little deeper into this, and it turned out that one of the parts of healthcare.gov that didn't work out really well was because one of the companies that was involved said, we're going to access the data using traditional relational database management technologies, as I described to you a minute ago, but that one of the subcomponents in there was built using big data technologies. So we had a fundamental architectural mismatch there that didn't work. And it's a really fascinating piece because apparently the conversations were, we're using things that don't work in your world. And the other contractor said, we don't understand what you're doing, so we're going to do the same thing we've always done. And that is what resulted in the mismatch that was there. Well, let's move on a little bit and talk about architectures that are typically managed. And many organizations will manage something called a process architecture, a systems architecture, a business architecture, a security architecture. Here's a new term I had heard recently, a tarchitecture or technical architecture, and of course finally we need to incorporate the data in this as well. So all of these architectures are important. Many companies manage one or more aspects of them, and that's great. If your company does something along those lines, consider yourselves in the top 10% performing organizations that are out there. Because the problem is, if management doesn't understand what these committees do, then they tend to confuse them with sort of debate societies and things like that. So let's look at a couple of definitions of information architecture, and I'm not real happy about these as well. Here's a couple of good ones. This one's from a good friend and colleague. The underlying information design principles upon which construction is based. Terrific. I don't like it, but it's a good definition. Another one from the internet, information architectures are plans guiding the transformation of strategic organizational needs into specific information systems development projects. Well, again, I can't really explain that to a C-level person in an elevator speech. A framework for providing a structured description of the enterprise's information assets, including structured and unstructured data, and the relation of these assets to business processes, management, and IT systems. Again, good definition there from Forrester. But where's the value? Where are the action words that are in there that management will really understand? This next book, Information First by Roger and Elaine Everndon, I recommend it highly to you. Information architecture is a foundational discipline describing the theories, principles, guidelines, standards, conventions, and factors for managing information as a resource. It produces drawings, charts, plans, documents, design, blueprints, templates, helping everybody make effective, efficient, and productive and innovative use of all types of information. Well, once again, it's a correct definition. It's a really good book. I don't want to take anything away from Roger and Elaine when they've done a terrific job on that book, but that definition just isn't helpful that's in there. Even our DIMBOK has a little bit of a challenge. It says that in information architecture is for defining the data needs of the enterprise and designing the master blueprints to meet those needs. Now, so there's a bunch of grumbling from Peter, and that doesn't help you really out in all of this. So if you're having trouble in your organization articulating what it is, one of the things I urge you to do is to go talk to your web people, because your web people really do get this information architecture as a content. When you do a Google search for information architecture, many of the diagrams that come out are very, very useful in there. Web people understand that the purpose of an information architecture is to sort things out. It's a great way of keeping straight the classification hierarchy, the labels, the tags, the navigation, the wayfinding, the search capabilities. And the information architecture connects people to the content that they're looking for in a web context. So with that as a definition, the way I like to describe data architecture is, first of all, to realize that all organizations have information architectures. Even if you've never had a consultant come in or nobody's ever developed a data model of any of the aspects of your organization, they still have information architectures. They exist. Some are better understood and documented and therefore more useful than others. So the way I like to describe an information architecture is to call it a common vocabulary for expressing integrated requirements, ensuring that the data assets are stored, arranged, managed, and used in support of organizational strategy. Now, there's a lot of definitions we've gone over. You're going to have to find one that works in your organization, but I suggest that starting out in the area of saying, this is the vocabulary so that we speak the same language that our systems speak, is a really good short elevator speech if you do get caught in one of those situations where the boss looks over at you and says, what's going on? What are you doing? So why is this stuff important? Well, one of the things we're trying to do is to keep track of which things we're talking about. And here are a whole bunch of different tanks. If I don't have a controlled vocabulary, it could be tank in the upper left-hand corner, which is a thing that runs around and has a gun and shoots. Or it could be the oil tanks in the upper right-hand corner, or the flying tanks that the Air Force uses to keep the planes up in the air, or the floating tanks that take oil across various amounts of oceans and things. Or it could be tanked, which is the definition of the guy in the middle and the bottom down there. Now, the architecture, of course, talks about what you're doing. Another component of architecture, too, though, is to realize that when a group like the U.S. military buys a tank, each tank that they buy creates 3 million plus new variables, values of data that come out of one tank. Now, that's an immense amount of information, and when you ask the question, how is this information used, most people don't have a very good idea. The information architecture is the thing that allows you to determine that use. And one of the things that the military might want to do when they get a hold of a bunch of tanks is to find out how long they're going to be good for. A tank has a shelf life. We don't want to fight this year's war with last year's tanks. And if we don't know what variables of those 3 million control their obsolescence, then we will spend much time and unnecessary cost storing, handling, somehow not maintaining the right vehicles in order to do this. And this was a study that we did actually for one of the groups where we were able to show that they were carrying $1.5 billion worth of expired inventory. Now, when we get into the models here, you would never build a house without an architectural sketch. Nobody would give you an estimate on how much that was going to cost unless you had finished the picture of what that's going to look like. Your construction workers from all over the world would still need that common language, again expressed by the model of the architecture components. If you want to verify the cost of those proposals, you can review them with somebody else. You can get a second opinion on it. If it was a really good house, you might want to build it again. And if we don't have the plans for the original house, it certainly won't be possible to recreate it. The example there is, of course, NASA can't get back to the moon because the people who went on the moon landing have retired at this point, and they're simply not available for this. And of course, you would never drill into the wall of your house without the map of the plumbing and the electric lines in there, because a drill and 120 volts of electricity do not make a happy meeting place. People need to understand architectures. And I show this picture, and oftentimes people laugh about it because they say, oh, that's a terrible architecture. Well, actually it's not. It's a very well understood architecture, and I'll bet there's plenty of people that could go in and add another layer to this particular building. But if I show you this picture here of a poor quality foundation, everybody, I'm hoping, would look at this picture and say there's absolutely no chance for me to build anything on there because the foundation is fatally flawed, and therefore I can't build anything on it at all that I will hope it will last on here. So again, the pictures here are, this may not be the best architecture, but at least it's a known architecture and it's something we can work with. Here it's a warning sign, do not build anything more here. And of course, management always thinks what they're buying is a very nice little house that looks like this. So we have to understand this. Now, let's get into a couple of architectural components that we'll talk about here. First one is a diagram that has been not taught in schools for some time on this. It just simply shows the context of the system and the system's boundaries. And you can see these are some of the architectural components. And if I said in here, in this component, that the Internal Revenue Service was part of this system, we would put it on the outside of the system rather than the inside of the system, because we simply can't work with the IRS. The IRS's rules are fixed in a different way than the systems that they're attempting to use. Here's another diagram, though, that shows too much detail in this case. And again, this is very, very dense. There's no way that anybody can make use of it. Here's a navigation diagram from one of those web developers that I was talking to you about. And you can see one of the menus is deeper than the other. They have different levels of depth and things, but it's a nice overall approach to doing this. Or here's another one that Jeff Kern put this together, where he shows that as far as he's concerned when he's developing websites, the information architecture is as important as the user interface and as important as the content on all this. Well, let's take a step back for a minute and recall that the reason we put databases together in the first place was so that programs could share data. Programs A, B, and C in this case in application domain 1 are sharing data from the brown database. But when you go to build another system here and put a green database out, we don't have any idea whether this data in the green database is the same or different as the brown database or the orange database that's in here. And so this lack of governance here, and this has come up with a suboptimal architecture. And architecture is focused on making sure that we are broader than just either the software or the database architecture. It's on system-wide use of data throughout the whole system, and that we're trying to address problems caused by exchange or interface problems. The goals of the architecture are much more strategic than they are operational on this. Now, a lot of you have seen me do this one as well and know that it's keyed on the number 42, and immediately you say, what on earth would the number 42 have to do with anything? Well, it turns out it's the meaning of life, the universe, and everything. If you go to the Hitchhiker's Guide to the Galaxy, there's a little bit of a fun story in there, and the fun story is that the white mice and the dolphins, who turn out to be running the world with us as the experiment, decided they'd like to find out the meaning of life. They create a gigantic supercomputer. It runs for 300 centuries and cranks up the number 42. Now, you may be listening and thinking to yourself, why am I listening to this? What do I care about the number 42? And you may not care about the number 42. But hopefully what I've done by talking about it for just under a minute there, you will understand that that is a fact that is paired with a meaning. It's also my age 13 years ago. There's a very meaningless fact as well, but that's the definition of data, is that 42 by itself is just a fact, and until we pair it with a meaning, it's the meaning of life, we have no real way of managing that. So the facts get paired with meanings, they become data, and that data then is paired with one or more requests, and it becomes information. And we can reuse the information when one fact is combined with multiple meanings in that case. Finally, in order to understand strategic use of the information here, we need to go one more level up, which is to get our strategic use of this information. The request of the information meets the business needs, but the intelligence gives us direction on where we should be going next. So all of this really represents and metadata architecture here, if you will, and I hope that you see quite easily that there's absolutely no way you can do anything in terms of using information strategically or even, using intelligence strategically or using information well if you don't have a good foundation of either data and information underneath it. And one more point on this chart before we move on, the two are so closely related there's no point in treating them separate. So pick one, call it either a data architecture or an information architecture. It makes no difference to me which one that you do. Just don't try to manage your data separate from your information. It becomes very difficult at that point. Now, data is expressed as architectures by details being organized into larger components. The larger components are then organized into models, and the models are then organized into architectures. This allows us to come back and look at the same parallelism in data, which is that attributes get into entities, entities are organized into models, and once again, the models are organized into architectures. You can see that the attributes are the most granular and the architectures are the most abstract. We tend to use models of architectures when we're talking about things that cross system boundaries in particular. And this is a diagram simply showing that there are networks of networks or architectures combined in order to show the linkages between the shipping networks, the chemical industry network, and the financial services network that all go into getting product from a chemical manufacturer to a customer in this case. Now, I mentioned before that how do these data structures support organizational strategy? Because they should. The first question that you have to ask is, were your systems explicitly designed to be integrated or otherwise work together? If not, then the chances that they will happen to work well together are a good guess. It's likely that your organization is spending 20 to 40% of its IT budget compensating for these poor data structures, and these data structures can't be helpful as long as their structure is unknown. So the top picture on the right there is a fancy restaurant that gives you a special dish for every plate that you have. And if somebody's bringing the dessert plate out and they trip and break the dish, they can't just go in the kitchen and grab the next dish. They've got to grab the right dish that went with that dessert. The architecture for that would be a very difficult process. Whereas in the bottom example, if we use standard plates, then we can have just grab the next plate. In this case, that architecture would support a speed rather than a care type of goal as being paramount in there. Again, your architecture is designed to achieve efficiency and effectiveness, but it's also designed to provide dexterity so that the organization can meet the various changing business conditions. And the reason these are important is because architectures tell you how and why the components interact, where should they go, when are they needed, how and why will the changes be implemented, what should be managed organization-wide, what should be managed locally, what standards should be adopted, what vendors should be chosen, what rules should govern the decisions, and what policies should guide the process. And these are just some of the things that it will do. Again, these data architectures are things that we take an organizational need, and this need becomes instantiated and integrated into this data architecture, which then authorizes and articulates specific information systems requirements. We do need to add a feedback loop in there as well to see if we've gotten it right, and if the world doesn't change, this is a great construct for us. However, most of us live in environments where the world is changing quite a bit, and this says to the organization that your architecture will need to evolve, hopefully ahead of where the business is evolving. So let's move now down into this concept of leveraging here. The key with leveraging, of course, is that we want our organizations to manage what I call their sole, non-depletable, non-degrading, durable strategic asset, their data. And they need to manage it within the organization, and they need to manage it with the partners with whom they change data. This means that we need to have leverage, and looking at this pile of data that's up there on the top of your screen, you can see that there are a group of people who have a process, pull on the lever, and they have a technology, the lever itself, and the fulcrum, which is the little diamond thing that we're going to use to pry this data up and make it work for the organization. That is our people, process, and technology piece, and we'll carry on that all the way through all of these seminars, which is to say that you really do need to have a three-legged approach, people, process, and technologies. If there's one thing that's been a problem, it's been organizations focusing too much on technology and thinking technology can solve the problem by itself. If we eliminate something that I call rot, data rot is data that is redundant, obsolete, or trivial, then I can achieve more leverage. And again, doing this in an asset-like manner allows us to simultaneously lower organizational IT costs and increase worker productivity. Now, all of your architectural models can be worked within this framework. Every component that you put together in architecture is either an as-is model or it's a to-be model. And similarly, it is at a conceptual, logical, or physical level in doing this. And our goal is, of course, to move all of these into a validated state. We don't want the things to be unvalidated. Every change in your information architecture can be mapped to a transformation in this framework. Very important concept on this. I'll probably get some questions later on. Let's press on for the moment and talk about the reason we need to change the way we build things is because we use a traditional application-centric development perspective, which says that the organization start out with a strategy, come up with some goals and objectives, and then a natural, logical next step seems to be that we go to systems and applications. And data and network systems are considered, but if I pick SAP at systems and applications, all of the conversations will be about how SAP does this and how SAP does that. The problems with this approach are that it ensures the data is formed to the applications, that the processes are narrowly formed around the applications, and that very little data reuse is possible given this particular model. It does become a problem for organizations. In a data-centric fashion, we take the same first two steps. We still want strategy and goals and objectives, but if the next step we take is our data and information needs organization-wide, then this can help us determine whether or not the software packages and the network solutions that we're looking at are in fact capable of meeting these organizational needs. If we do it this way, the data and information needs are described from an organization-wide perspective. The systems support the data needs and complement the organizational flows, and we can finally get maximum data and information reuse. Now, just a little word on this. The reason this is important here is because the primary objective of object-oriented software in the past has been to reuse software, yet every academic study that we look at shows that we are only using a tiny, tiny fraction of the software that we anticipate reusing in the long run. Data, which is a much easier, more static concept to describe, is much easier to work with from a reuse perspective, but achieves much less reuse in general because of that organizational data rot. I'll just give you a measure. If your organization has data on people, customers, in less than 17 locations, you are above average. That's a pretty scary statistic, isn't it? See, data architecture is very poorly understood because they don't understand the value that it comes. And it's not very well explained either because there's been little opportunity for people to gain experience from it. It doesn't occur in the standard undergraduates and only some of the graduate level courses that are out there. And it's indirectly experienced. So people don't understand that because I didn't understand my data architecture, I selected a software package that was really not the one that supported our organization. Another thing to understand about data architecture is that we really only need to look at it as a component. We do not need to manage the entire architecture simultaneously. We need to understand which components are interacting in our world and that are relevant to the decision that we're trying to do here. So I've got a couple of examples here. It's just an intersection of business functionality and subsets of the organizational technology used to implement that. So it's essentially a crosshatch view there. Or another one that we call our common metadata model is that the engineering is going to focus on one component as the analysis use. So this might be 3 benefits modules from PeopleSoft and not all the others in there. If we do that, we can start to get to what we really want to do, is to identify some specific engineering standards. People wouldn't be building your houses out of certain things if they weren't standard. Most importantly, my favorite at the bottom, almost all the way to the right, are the concrete bricks that are down there. Some of you have seen me do this on other webinars where we talk about the uses of these bricks in a lot of different contexts. But the point is, these bricks are well behaved, they're well made, they're standard, they have the same processes that we can associate with them, and that we can build a building that may be 4 to 10 stories tall with a foundation of this, but you certainly wouldn't build a skyscraper on this because they are an inappropriate usage for that. That's probably going to be more of a steel-framed building. So between these architectural work products and these engineering standards, we can now start to look at how these systems are laid out. And here's one example of a decomposition describing the system's architecture from a functional decomposition perspective. You can see here there are 3 main processes associated with the system, and that process 1 is more complicated than process 2 and process 3. Again, a picture like this is literally worth 1,000 words, or maybe in many cases several thousand hours of consulting time if somebody has to come in and help you out with this. Here also is another decomposition. This is a 3-level decomposition from a government pay system here. And you can see again, it's the pay and personnel module with employment, personnel administration, payroll, development, training administration, and health and safety as the next levels down. And of course, each of those levels has multiple levels down underneath it as well. Very interesting in this particular architectural representation, you'll notice the one component that seems to be missing is development, which seems to have a not applicable sign attached to that. Here's an even more complex model here. Again, you can see this is just a description of one of the healthcare systems that we're working with. It's got modules for patient administration, appointments, nursing, laboratory, pharmacy, radiology, clinical. I won't read them to you. You can see it for yourself here. Let's look at another example. This is in the Commonwealth of Virginia, the way our State Department of Social Services used to function. And I'm going to show you this model, a combination of the 2 architectures I showed you before. 1, the whole architecture, and 2, the parts that are in here. So the parts that are in here are inclusive of a couple of different perspectives. The taxpayers, when they look at the Department of Social Services here in Virginia, they see social service programs, they see taxpayer benefits, they see themselves as taxpayers, and as taxpayers they make payments. Great. Now notice the payments piece stayed the same because it's common to both the taxpayer view and the client view. However, in the client view, they look at it differently. They look at interactions with local welfare agencies, they look at clients themselves, and they look at client benefits, and those payments come in and help them out from that perspective. Although sometimes the clients also receive payments directly from the system. In this particular architecture here, the government governance part is the most complex, and that's what you're seeing now with the governmental resources governance, the governments that are involved. We have the state government, and we have many local governments that are involved in this. Notice again, payments still comes common to all that as well. State Department of Social Services, a social service programs board, and the policy approval finish that particular out. Then we have a program delivery view, which allows us to see how the programs are being implemented by local agencies in conjunction with their service delivery partners to help out their clients. And then, of course, we have the vendor view of all of this that allows us to see that social service programs clients' payments are all tied to the welfare agencies who deliver the goods and services via the vendors that go in there. I know that's a little bit cumbersome here, and what you're seeing now is the entire architecture that puts this all together. When we did this agency was able to very crystal clear see, first of all, that we had made some errors the first time we did it. And after we improved those errors, you're looking at the more new and improved version of it, they then started using this themselves and pointing, I'm here, we're trying to do this, et cetera, et cetera. Let's get into some more specific examples in here. So let's drop into our first one. It's a software package implementation here. Now, I know there aren't too many green screen applications out there, but there are a bunch that are out there. And this particular package was going from the green screen that you see in the upper left-hand corner there. It's actually blue, but we call them green screen applications in there. And it's going to be changed to a very significantly different program with a WIMP interface, Windows icons, mice, and pointers, what you'd expect in today's environment. The real key to this, however, was that the changes that had to be made to this system took it from a very nice custom system, where, we had we had one screen that handled the functions for everybody that needed to do this. And that function of one screen was now being broken up across 23 separate screens. You could see that's going to be a big change to the way in which this organization processes the applications on here. And management, faced with that knowledge, also felt that the workforce might have problems adjusting to a simultaneous change, which was that this system was now moving from personal identification via the Social Security number to a non-generic person identifier in this. And they asked the consultants, maybe we should back off that change of going from Social Security number to person ID and just keep it a Social Security number, because they're going to have trouble enough managing all these changes that are involved in here. And the answer from the consultants was, well, that's not a very big change. Well, let's use our architecture to figure out how big a change it actually is. Let's put some meat on the bones, if you will, of what that architecture should look like. First of all, we're looking at the process metadata, or the process architecture within the PeopleSoft system. It starts off with a home page, and each home page is related to one or more business process names, and each business process name is related to one or more business process component names, and each business process component name is related to one or more business process component steps. So in one simple page here, I've given you a diagram that can help you decode something that looks like this, which is the answer to a people query, where we come back and ask the PeopleSoft system to tell us about how it actually works. In this case, you can see that the home page is the base benefits that are there. The business process name is administer base benefits. The four components that are shown here are manage benefit enrollments, manage dependents benefits, manage leave accruals, and report benefit participation. And then finally, each of those has one or more steps that are associated with it in order to look at this. Now, when we look at these overall diagrams, and by the way, this has got all of the processes labeled in this particular sheet that's here, it allows us to go back up and map onto the system architecture where these processes come from. And I'll show you here again the home page. You see I've circled it there in gray with the number 7. That means there were 7 home pages that we were able to identify on the system. The business process name, 39 of them are related. That's the pink that I'm showing up there. Now I've got an orange thing, which are the business process component names, and finally the business process component step names. Total of 822 step names that reside in 180 components that are contained in 39 processes underneath 7 home pages. Once I have this meta model of the system, I can connect the rest of the pieces to this. Now, I will say for PeopleSoft, they have a very nicely put together, nicely architected system, and this meta model actually is a very good key for understanding how it's architected. But now what I'm trying to do is answer the question, how big a change is it to make all of the instances of person ID revert back to Social Security number? In order to answer that question, I'm going to have to find out what panels, what tables, and what business process component steps interact with them. Once I have this information, I can put this into a little structured database that I create. I usually use Access or SQL Server or something like that, depending on the complexity of the system, and I can start running some queries against it. And these queries give me the ability to answer the question, how much is it going to cost? What you're seeing here is that in this particular instance for the system, there were 1,400 panels that would require changes to go from person ID back to Social Security number. And if I put a measure of 15 minutes per change, that gave me 350 labor hours of time to go through and make those changes. Similarly, under tables, there were 1,500 tables that needed changes. And again, if I put 15 minutes per change, that gives me 375 labor hours that are associated with that. And in the business process component step names, we also had to make some changes there. There were 984 of those instances. Again, just putting a measure of 15 minutes per change on it, I got 250 labor hours, 246 labor hours out of that. And when I have those hours, almost 1,000 hours, I can now time that out at $200 an hour, which is the rate we were paying the consultants to do this work. And it turned out that this work was valued at almost $200,000, $194,000. Now, you might ask yourself, first of all, why would anybody pay $200,000 to make the system worse instead of better? Remember, management tends not to understand these architectural components that we're talking about, and so all they do is they see, well, if we're not going to use new person ID, which nobody knows what that is, and we're going to continue to use Social Security number, how could that be making the system worse? Luckily here in Virginia, though, we had an interesting component where if we were going to make a change to the base level of the system, we also then had to multiply that base for the next 5 upgrades. So if I'm going to make $200,000 worth of changes to that system, I have to budget for the fact that I'm going to have to make the same $200,000 worth of changes to the system and count at least the next 5 upgrades that I do in this, raising my price up to $1 million. Now, this is where we come back around and say that the total project budget of $5 million, and when the consultants say it's not a big deal to change that, here we've got $1 million out of $5 million. That to me sounds like 20% of the overall budget and a very, very difficult way to justify decreasing the utility of the system. So we've used the system architecture via its process diagrams, its data architecture, and in this case through the menu structure to identify the specifics of what needs to be changed. And I'm probably also underestimating, because if you look at this diagram here, the most important number on it is 15 minutes. The likelihood that somebody will ever be able to make those changes perfectly in 15 minutes is very unlikely. So I've probably underestimated the cost of that change instead of overestimating it. Our second example then from this is a donor center that we've been working with for a while. And the institute here has been fighting cancer for a long time. There are 500 researchers and staff, 12,000 patients annually. And the problem that they were running into is that occasionally somebody would call them up and say, hey, I'm calling from the National Cancer Institute. Don't worry, they don't really do this. And if you can find me 6,000 patients that you've got in there that have ear cancer, we've got a $5 million grant left over this year that we can give it to you. Well, the problem was, again, there's no such thing as ear cancer, so I'm really making up the example here, but it took them a month to do this because they actually had to go after these files and open them up one at a time to try and find out and count the number of instances of ear cancer that they had, because their data management practices were not supportive of their organizational strategy. The Cancer Center functions very, very well, but still has a challenge around this. And the current state of the architecture, using these diagrams that you see here, you can see how many different things were diagnosed in many different structures within the target environment. They had a separate structure for patient billing data, diagnoses and physicians, a duplicative structure of the patient diagnoses and physicians that were in there that had different information from it from a different set of source systems that had to be reconciled, and finally the patient registry components that were on the end of this. Our approach to this was to simplify the overall process and give them everything in one box after it had been, we'll say, normalized. I'm not using it in the formal sense, but equalized, all other things being equal. We tried to make the data as homogeneous as possible in order to do this. Now, this leads us to another interesting piece, which is that the people who went through these files were the people who were the expert researchers in this field. And if there's a task that we find that would be really beneath them, it'd be looking through these files. But they were the only ones who could decode the information on there because they understood the various diagnostic codes and things like that that they were looking at. So again, it's a problem if you've got inappropriate people doing the wrong set of things. In fact, when we look at most of what we call our data scientist community, they spend an inordinate amount of time looking around for things, manipulating data, and 20% of their time actually doing the analysis of the data, which means they are spending 80% of their time not being productive. And if we could just take that and move it to from 80% unproductive to 60% unproductive, we would have doubled these data scientists' productivity here. Again, we've done this for several organizations, and they are just pleased as punch that their people are no longer spending their time manipulating digital data, but they're using those big brains on solving problems like curing cancer and things like that. And the measures are not always about money, although a lot of people like to look at this. But once we had integrated this data into a more coherent data architecture, and we had automated a number of the existing manual processes, the data was able to be passed effectively and efficiently. We were able to eliminate the inconsistencies. They could do cross-analysis and reduce the turnaround time on these. In this case, giving us safe matches, we currently have a measure of 3 out of 10, and if this process works the way we want it to, it will be up to 6 out of 10 in order to do that. Our final example here now, a little bit more detailed, a little bit more numbers oriented. And the key, of course, is that we have to remember that these engineering and architectural concepts are highly related. You can't have one without the other. If you have an architecture without engineers, the architects aren't capable of building to the detail that they need to have. The engineers aren't similarly clear, able to see the big pictures that they need to have in order to do this. And you'll see this in building anything large and complex. There's a contractor and a manufacturer that they use in order to do this. Well, again, these engineering concepts are just absolutely missing for most organizations. Again, I like to use this particular diagram because it is taller than I am, this machine here that you're looking at. It has a clutch. You may never see a mixer with a clutch on it, but boy, this one's got a clutch on it. It was built in 1942, and if you remember in 1942, we were losing a war. And when we were losing the war, we didn't know how long it was going to last or whether we would in fact come out on top or not on this. And so they over-engineered this particular machine. The reason they did that is because they stuck this machine, as well as 2,000 sailors, on a ship called the Midway. I've got a smidgen of the picture of it there in the bottom left-hand corner. And the Midway, of course, went off and won a bunch of battles in conjunction with the other forces that were out there fighting World War II. Now, this over-engineered machine was, we didn't know how long the war was going to last. We didn't know how many breakfasts we need to fill for these people. But what we wanted to make sure was that nobody went hungry. And if we had tried to fill the business need with this little KitchenAid mixer, and again, I'm not picking on KitchenAid, the duty cycle for a kitchen for a family of 4 to 6 or even 8 people is very different from feeding 2,000 sailors pancakes every single morning. So if that had been made in 1942, the little red one, there's very unlikely it would in fact still be in use today. It would burn out. The duty cycles simply are not able to take that on. From an architectural perspective, this is crucial. If we don't use the right architectural components, we're never going to be able to use what we're trying to meet in terms of the business needs. So the final story then of architecture in use is a challenge that this organization had around looking at NSNs or SKUs, depending on whether you're government or retail sector looking at these things. NSN is National Stock Number, SKU is a stock keeper's unit. These are maintained in a catalog, and this catalog belonged to the Defense Logistics Agency. Over the years, they had stored most of the data in what we call clear text or comments fields, meaning it was free-form, not really structured in the way we'd like it to be. The original approach to this was that we can't understand this architecture, and therefore we're going to have to manually extract all of this information out. However, that left the data structuring problem completely unresolved, and I was just very fortunate to be invited in to come in and put a solution in place that involved a improvable text extraction process that converted this non-tabular data into tabular data. I was particularly proud of the fact that we saved the government more than $5 million on this particular exercise, but this is the first time I'd ever saved somebody a person century of work. You've all heard of person days, person months, person years. I got a person century out of this one. Let's take a look at how it worked. Again, the architecture for this system, I want you to just picture it in your mind here for a second. It was a hierarchical database. It was one of those databases that I told you we don't even teach people that they exist anymore. Hierarchical databases are a perfectly fine, valid way of using them in organizations. In fact, if you took hierarchical databases away from the top 10 banks, they would all stop working tomorrow. There's simply no way that the relational model is able to provide the kind of speed that these hierarchical platforms provide. That hierarchical platform had been re-engineered once into Oracle. Oracle, as you all know, is a relational database management platform. However, Oracle can be made to work with a little bit of effort. It can be made to work as a hierarchical database. And in fact, they had been very successful at doing this. Now, the interesting thing you might ask was, first of all, why? And the answer was, if they didn't change the database to make it work the way the old database worked, they would have had to change all of their application software that was accessing the hierarchical database. But because they were clever enough to fool Oracle into thinking it was a hierarchical database, they could keep it running with the same software. Now, this was a trick they had tried in the 80s. Now they were moving up into the 2000s in order to change this particular system. And remember what our problem is. From an architectural perspective, we need to grab all of this data out of the existing system and structure it in a way that will make sense for the new system to do. Now, bear with me for a minute. It's a little bit of chartiness on here. What I'm showing here are four columns. The first one is the weeks going 1 through 18. Second one is the unmatched columns. The third one is the ignorable items. And the third one is the matched columns. And I've just drawn a circle around the first week's worth of work that showed that we didn't match any items. We didn't produce anything of tangible business value, in fact, until the fourth week, when we, in fact, managed to figure out that we had matched 55% of the items that were there. So in 4 weeks, we had, in fact, pulled half of the architectural components out of this system and been able to derive them. That was a win right there. We could have stopped, but everybody knows that if you tweak it a little bit more, you can get better. When do you stop? And the answer is when you reach the point of diminishing returns. Now notice also the ignorable items that I had on this went from 1% almost to 12% at the end of those 4 weeks, and the unmatched items started at 31%, went down to 21.20, and then back up to 32. So as we're adjusting the algorithm in order to do this, we were achieving certain results. Now, this is okay, but it wasn't optimal. Where do we get to the point of determining the optimal returns? Well, at week 18, and by the way, the weeks were considered to be one full-time person. Actually, it was a team of two. We always use 2 people on a project, but they were both working half-time on the project. So it was a 40-hour project with a fixed cost, and we could determine precisely the value that was received from it. You'll notice that the unmatched items eventually dropped their way down to 7.5%, meaning we'd taken the original problem space down to 7.5% of the original problems. Also, the ignorable items, we were able very confidently to say that 22.62% of the data that was in those 2 million NSNs was of absolutely no use to the business. It was rotten. And finally, the number of items that were matched, we went from 68 to just about 70%. And you can see we were reaching the top of the curve or the point of diminishing returns when we looked at it. So once again, we want to put that onto a spreadsheet here and look at the 2 million NSNs, 5 minutes to clean all these things, how many weeks in a year, how many work days in a week. You know, you get the picture here. Here is my 92.6 total person years, and on the very bottom is that $5.5 million. But once again, I've played a trick here because I've made an assumption that it's going to take them only 5 minutes to change all of those pieces. Very, very unlikely that's going to be the case, in fact. And so if you double that number, you've got 2 person centuries and $10 million, et cetera, et cetera, et cetera here. So we've reached the top of the hour. Let me just review a couple of things before we get ready for the Q&A session. And really what I want you to take away from this is that an information architecture is a structure of data-based, not database, data-based information assets that support the implementation of strategy, that most organizations have data assets that are not helpful of these strategies, and the question is how can organizations more effectively use their architectures to support strategy? So what do we mean by using the strategy? What do we mean by using the information architecture? And that's the application of these data assets towards the strategic objectives. We can measure this by the maturity of their data management practices, and we can accomplish it through data-centric development practices in there. So the organization, in order to achieve best use of its information architecture, is continuous redevelopment. Using these architectural components in a re-engineering format, iterative incremental approach, focusing on one component at a time and applying a formal transformation process. That process is what I'm going to dive into in Kansas City in a big way when I get out there later this week. And we're at the top of the hour. I want to remind you the next webinar coming up is in June. On June 10th, we're going to be looking at a book I put out last year called Monetizing Data Management, how to take this stuff and save yourself some money around this. So we're at the Q&A section. Megan, I think you jump back on and see if we have any questions from people.
All right, thanks, Peter. That was a great presentation. Now it's time for you guys to ask your questions. Time for just whatever you got. So just click on the Q&A window feature at the top of your screen, and you should be able to submit your questions through that Q&A window. And we've already had some come in, so let's jump right into it. Let's see here. The first one is, models need to use business definitions and not dictionary definitions. The same goes for data architecture. How do you see this working out for the architecture artifacts?
Would you read the first part of that again, Megan?
Models need to use business definitions and not dictionary definitions.
Good.
The same goes for data architecture.
Great. I just wanted to make sure I understood the premise there, first of all. And the question is absolutely dead on correct. These terms have to mean something in your organization. While it's useful to go to the dictionary and to get precise words, and we in the data modeling, data architecting community love to use dictionaries for this, the more important thing is that the stuff has to mean something to the business people as well. So my favorite example of that type of usage is a company you may have heard of called Nokia. It's been about 4 years with them on and off. Great company, very engineering-focused organization. And if during a meeting we used a term or a TLA being an acronym for a 3-letter acronym, or any other type of acronym that they didn't understand, they would talk about it for a minute, and then they would have a side conversation arguing about whether that term should be added to their glossary, their data dictionary, their main reference point from which they all used. And as the questioner said correctly, we want to use the business definitions here, the things that mean something to them. So when I was talking about tanks earlier, the oil companies are going to take a very different perspective than the military is going to take, or that a court, if you say that the driver of that vehicle was tanked in there. So it's very, very important to use those. The question I think that the caller, or the question is asking is, how do we adjust for that in an architecture piece? And the key is that you need to define the information architecture for your business in a way that complements your business. And I'm going to go flip back to my data-centric development chart here. So let me get right on that one page there. See if I get that right. Yes. This data-centric perspective here really ensures that you will be speaking the same language as the business. Because what happens in most cases is that IT or the business abrogates its responsibility to the business and says, go ahead, IT, you can pick the package in order to do that. That is so wrong, and we see so many organizations compensating for poorly implemented software packages. By the way, it's not the software's fault. The software works really well. The problem is it doesn't match what the organization's strategy is. So by defining your data and information needs, if you will, the information layer objects as step 3 of this approach, instead of buying software first, which seems like a natural thing to do, but remember, the software changes. The software is developed to be the lowest common denominator. In fact, I'll tell a funny little SAP story. SAP, in its first version that they had, was developed in the late 1990s, and they said, we're going to have paperless offices, so we don't need any print functionality in SAP. Well, if you've ever ridden on Amtrak, you know that Amtrak uses SAP, and they can produce tickets. So clearly that particular, although they do produce electronic tickets, let's not be silly about this, they can now do electronic tickets the same way the airlines can. But what you're seeing here is that this data and information layer is where these things need to be defined and maintained. And within that architecture, that is how you're going to keep those products and services instantiated. We did the same thing with the DoD data architecture back in the early 90s as well, and I'm very pleased to say it's been one of the best examples of government investing in a process in architecture, because not only did the DoD continue to use that architecture for 25 years, but other parts of the federal government have looked at DoD and said, well, if the Department of Defense can do it, then we ought to be able to do it as well. So I hope I've answered the question. If it's not, please ask for additional information, and then we can go back onto it. Thanks, Megan.
Okay, great. And we've got a lot coming in, so we'll keep it rolling. The next question is, are management set out to develop a complete data and information model for the whole company? How can I persuade them to take a more practical, opportunistic approach?
That is a great question. And gosh, it sounds like if you've got management actually doing that, that should be what they want to do, right? So let's take a fairly typical approach that organizations do. And the typical approach to this is that they try to do everything. Now, if you try to do everything, it's kind of like having everybody watch out for your data quality problems. People are going to be less involved in certain areas than in other areas in order to do this. So what I would suggest to them is that, first of all, the enterprise architecture is a living document, as we stated in the piece of this, and that not all of it is going to be immediately useful to the organization at any one specific point in time. But let's say that you've got a project going on, and I'm just going to say it's going to go on in payroll. So let's develop that portion of the architecture in advance of selecting a payroll system. Some of you have read some of my books, and one of the examples I beat quite a while in the book is matching payroll functionality to the architectural requirements of the organization. If the payroll system that you're purchasing doesn't support job sharing and doesn't support teamwork in this type of a capacity, or moonlighting, these could be important components that you're then going to have to develop workarounds in order to do. So if you develop that data and information layer first, that can better help you select the packages that go into that. Now, the next thing that you might want to try with them as an argument on this is to say, well, how long do you think it will take to cover all of the information needs of this organization? And if the answer is 3 years, then what you'll have in 3 years is a great view of the way the organization looked 3 years ago. If your business doesn't change, you don't have a problem. But last time I looked, most of our businesses were changing. And so the idea is, let's put a framework and a skeleton out there in place, and let's get detailed about the parts where we can deliver business value around this. It may be 1, 2, or 3 components of the information architecture that are more useful right away, but let's also build into every time we touch a system from a maintenance perspective. Let's take that and make a deliverable from that maintenance activity be a reverse engineering of the as-is architectural components, and let's use that to flesh it out. We'll also be able to tell by looking at the map of the completeness of the architecture which components have to be re-engineered, which ones have not had to be re-engineered, and it'll give us a good idea of progress around that as well. So again, the caller sentiments are something that are very, very reasonable, right? Yeah, gosh, I finally got management to pay attention to this stuff, and now they want to go build the entire thing at once. Well, I would absolutely agree with the question and say, let's try it in small chunks, let's get good at it, let's practice it, and then let's practice it becoming good at maintaining it too, because if I put it up and put it on the wall, by the time I've done that, it's already out of date. I hope that answered the question. If not, feel free to give us a shout and we'll dive in with some more reasons. You said you had a bunch of questions on Megan, and that means you want me to stop talking.
No, that's great. The next one is, there are 10 functions in the DMBOK wheel. How and why do you focus on only 5 integrated DM practices? Help us understand your reasoning.
That's a great question. So many of you know I am past president of DAMA, and I absolutely support the DMBOK, and we've done some great things around the DIMBOK. The difference between the DIMBOK wheel and what I was showing on those two charts there is instructive. So go back in and take a look. Here's first of all the DIMBOK wheel, which Deborah Henderson and the group put together, did a great job of this. So what you see there is architecture management, data management. These are data management functions that we're looking at in there. And again, you can see them, they go around all governed together, held together by governance at the center of this particular model. Now, what I was putting up earlier here is this 5 practice area. And these are the things that you need to get good at in order to go forward. So these are, if you will, an orthogonal relationship to what goes on in the DIMBOK wheel. The DIMBOK wheel shows the very nice limits and talks to them about the technologies and practice, the things that they're supposed to be working around there. Here is what you do to make these things work. All 5 of these functions on this chart apply to each of the 10 areas of the DIMBOK wheel. And that is an important component to understand, just as the weak link in the chain. If you're doing 4 out of 5 of these things well and 1 poorly, you will still end up with data management practice problems. So important to remember that. I hope that clears that up. A great question.
All right, and the next question is, can you compare and contrast a data-centric development versus SSDLC?
The SSDLC?
That is what it says, SSDLC.
I'm afraid I don't know what the SSDLC is, but the SDLC, Systems Development Lifecycle, is an interesting story in itself. I don't know if I've actually written this one down. Let's be very careful on this. So the systems development life cycle that we teach undergraduates and future business leaders and future technology leaders is a work of fiction that was made up by a writer for Look magazine in the year I was born, 1959. It was then copied into a textbook, the first textbook on software engineering that was developed by NATO in the year 1969, 10 years after that. When you look at these incorrect things, and the fiction that's in it is the idea that we can simultaneously develop our data objects at the same time as we develop our process objects. And it's absurd. Our data objects persist across systems and system development activities. And if they don't persist, then they shouldn't be stored in a database. So let me pull up another chart here, because I think that's a good one. There we go. These 2 charts right here. You can see that the brown, the orange, and the green database are going to persist beyond those programs. The programs may stay the same, the programs may change, but the data is substantially more stable as it looks out across these things. And what we're really trying to focus on here is to say, look, you shouldn't start any software programming at all unless you can answer the following question about your data. The question is, which data items from your current inventory are you going to reuse on this agile project? And therefore, which data items need to be created in advance of starting to code the agile project because you can't find any that you can reuse? If you can't answer that question, you don't know enough about your data requirements to spend 1 penny on software development processes. So these objects, the data objects, persist across these systems and among the various partners that we're interchanging data with. And that's, if you're trying to develop them in the middle of a software development exercise, the only alternative for the group in order to keep making progress is to create more siloed data. Now don't worry, if you do, it'll keep companies like mine in business. I'm very happy about that. But I would rather people do it the correct way, which is to specify the databases first and then to authorize the application of funds towards developing software. I hope that answers your question. I think it did pretty well.
All right, and we did confirm that that was SDLC.
Very good, thanks.
All right.
Now, if you want to hear more about that, hit me up at a conference and I'll tell you over a beer the full story behind that.
And the next question is, I have a large number of analysts that spend their time organizing and preparing data using SAS to get it into a format usable for their analysis. How do I go about changing this practice so that IT spends its time teeing up the data for the analysis so they make better use of their time.
So you just got my 80-20 rule argument right there, and that's perfect. We've done a number of these for organizations, and one of the first things I would do is to measure the productivity of the group that's there in order to make the case on this. So do work study motions, back to the old time, the stopwatches and things, and you will find that these folks are much less productive than they'd like to be, and they're quite frankly not really good, although some of the groups get very practiced and get really good at data management, but what we really want them to be is analysts, isn't it? So if you can help them to understand, and I have a chart from another, see if I can find this one. I'm not going to look for it, but I have another chart that we did for a chemical company that we actually mapped this process out and showed it to them. And their first response to us was, wow, that's great. We've never actually had that much information on what our analysts do, so we didn't really know. And now we see what they do and how they spend their time. We can start addressing the challenges that are associated with them spending too much time around that. So we developed some relatively rudimentary data management practices around those really productive knowledge workers, and we're able to make the entire group much more productive as a result. I'm guessing that there's somebody in IT that you're able to converse with and figure out what it is they want. But I'm guessing IT probably doesn't know SAS, and so that may be the barrier that's there. Or somebody's just decided that the productivity of the group at its current level is sufficient, and therefore they don't need to have a whole lot of additional things that go around that in order to get it going. It is a tough problem, and it's pervasive, absolutely pervasive in terms of what sorts of things we see out there in the real world. There's just very smart people. Heck, cancer researchers who are going through files one by one looking for instances of ear cancer. That's not the way you put somebody in productive mode. So great question. I hope I answered it for you.
Okay, great. And the next one is, how do you establish architecture for enterprise information management culture, and what do you consider?
So good things to consider. One of the things that we consider specifically is to look at the organizational readiness. Most organizations are at different levels of readiness, so it's very unlikely that one size fits all. A good way to look at it, though, is the capability maturity model out of Carnegie Mellon, and I'll put in a plug for Melanie Macca, who's been pushing really hard on getting this maturity model out. Once we get that out, I'm sure we're going to have a description of it here in one of our webinar series that's coming up. It is open, by the way, for review, so if you're really interested in seeing this maturity model and taking a look at the first version and commenting on it, please get in touch with me or Google Melanie Macca at FEI, and her name will come up to the top, and just write her an email and tell her, Peter said you could take a look at this. She's loved to get some reviewers on this. We've got about 150 people looking at it right now. I pity her having to go through all those comments that are there. But the key there is to say, if the organization is at a low level of readiness, then don't try and oversell them a program that's not going to be able to be absorbed by the organization. Let's take some baby steps. Let's keep a conceptual model perhaps as the first level of the enterprise model. And if that model works for a couple of years, then consider moving it to a logical structure and maybe maintaining it as a logical structure. Even if you can't get the entire enterprise to participate, if you do your group and show that your group is governing its data better than the other group, and therefore you're achieving significant business results as an outcome on that, that is terrific, because then they'll look at your group and the other group and say, what's the difference? Say, well, we are using enterprise architecture concepts and the other group is not yet. And if we do that, we can expect some similar benefits to be quantified in that area. We're going to dive into that topic a little bit more next month when we do the monetizing talk, because that's what I look at there, is how to put some dollars and cents costs on these things and really make management pay attention, because when you wave money under their nose, they tend to look around and say, yeah, I guess we should have a conversation about that.
Okay, the next question is, how would you articulate the difference between a data modeler and a data architect? There seems like a lot of overlap at the very least. Some
Absolutely.
Think they are identical. Are they?
So great question, and a great premise. They are related in here, and many of the skill sets are in fact similar, but not all. It's just like you don't necessarily want to take a programmer and make them into an analyst, or an analyst into a programmer. Modelers tend to be downward facing and more detail oriented. Architects tend to be focused on the higher level, the higher levels of abstraction, the big pictures that are up there. And these do represent different skill sets that we have. We found that with training, we can take almost any modeler and give them some architectural background so that they will think more architecturally. And we can take virtually any architect and show them that data modeling is an important part of what they do. And so if they think about these things from the arrangement of the components, they'll be further down in their practice areas. But they are not the same. And so as the questioner points out, you can train a little bit into them and get some of them to work in there, but don't automatically assume that the people who are very happy with the detail associated with data modeling are going to be good architects and vice versa. It's really up to you to work with your HR department in that. And I'll refer you back to a webinar we did back in March that Megan had helped put together for us, where my colleagues Mehmet Oran and Eva Smith were on talking about career days. And we actually did talk about the pathward upward for people who want to do advance in this area. That's probably worth digging up as a reference material. I'm sure it's out there on the Dataversity website to download for another replay or something like that. Anyway, I hope I answered that question. That's certainly a good one as well.
All right, the next one is, do you buy into the data lake concept to big data, where we just need to put lots of data in there and then they will figure it out? I am afraid this approach will put a lot of rot in the big data platform that will cost money and add to the noise and confusion.
What an interesting question. So first of all, the data lake metaphor, as far as I know, was started by our friend Tom Redman, where you think of data as a lake, and there's certainly an amount of pollution in the lake in there. One of the things I like organizations to say when talking about their data lakes is that right now we can tell you that all of our data is of unknown quality. Now that's a very scary statement. If it's true in your organization, it should cause somebody to start paying attention. So try that vocabulary on. All of our data is of unknown quality. Now, if it's not, don't say it, but in many organizations it's a very true statement in there. The big data component of it comes in, and I've got another talk that I've been doing recently called Demystifying Big Data, which really takes some of this allure out of the big data piece. Don't worry, there's lots of good things in big data technologies, but since we can't identify big data objectively, it's very difficult to label anything as either big data or little data on this. The caller is asking the question, though, because one of the things that big data techniques have been developed in response to is that if you hand a pile of kind of not well-formed data to somebody and say, create a program here that does this, their first question is going to be, what is it? What are the rules that govern it? And all the rest of this. And big data sources tend not to have rules that govern them that way. So big data techniques are very good at taking these data lakes and sort of figuring out that there are some fish, and there's an old rotten car, and there's some old trees, and maybe some dead birds that have fallen into the lake. You know, in other words, what are the major things that are in the lake? But it can't give you the precise components of where is the rusty car, and where are the the skeletons of the dinosaurs that you're looking for, if you will, in there. So big data techniques give us some ability to look at the data that is not well understood and try to make sense out of it. But making sense out of it and leveraging it are two very, very different things. You have to make sense out of it before you can leverage it, but if you just make sense out of it, it does not mean that you will be able to leverage. And the analogy here, I've got this picture of the church up on the screen right now. If you can imagine that church, before it was built, it was a bunch of piles of bricks. There were certainly some clock components and chimneys and roofing tiles and doors and windows in a big pile. Yeah, that's what big data is going to tell you is out there. It's not going to tell you that you can make that into a church, a really nice looking church. I assume it's a church. It may be a school for all I know. Come to think of it, it was from Philadelphia, so maybe it is one of the schools up there. But these big data techniques are going to give you the ability to gain further into it. And the way I like to say it is that let's pretend that your eyeballs, your human limitations are that you can see into the room that you're in. If you had X-ray vision, you could see into the next room. But X-ray vision would be really not useful at all if you could see into the next room and the next room and the next room and the next room, and in fact into the next office building and anything else, because you wouldn't really know what you were looking at. So it extends our ability to understand what the value is of the data, but it doesn't give us this wonderful, perfect thing where we could do it like it works on CSI on the cop shows on television, right? Never it works out that way in real life. So again, I hope that answered it. I was sort of long-winded, but I think you get the sense of what I'm talking about there.
Okay, great. And we have about 4 questions left, so we'll see what we can get through. And if we can't get to something, then we will include it in the follow-up email. And the next question is, where do you see the role of data governance in data architecture strategy?
Fabulous. Okay, so governance is your best weapon in order to get this stuff started. And I shouldn't say the word weapon, it's best tool that you can use. The key is and many groups are being audited and then faulted for not having data governance. So when you're told to put in data governance, you need to specify what data governance is going to do. And one of the things I like to do is to say that data governance has an absolute gateway function on whether IT projects are ready to go or not. Because most people don't understand the data requirements, and the data requirements are done very poorly, governance can ensure that we put a higher priority on these items and make them more useful to our organizations. That's just one example. Governance, though, is a great place to take a look at, and you'll notice we did put it at the center of our DIMBOK wheel because we do believe it applies to all of the various wedges that are out there.
All right, and the next one is, noticed you referenced some elements similar to what Zachman or other enterprise frameworks reference. Do you feel that these frameworks help to define the elements of an information architecture?
Absolutely, and again, this is the thing that we all are so grateful to John doing. My question to my undergraduate classes for their final exam after we've studied the Zachman framework is, why hasn't anybody improved on the Zachman framework? And the answer is very simple. Anytime you come up with something that you're trying to put into a framework where you talk about the 6 interrogatives and the different levels of abstraction that they're facing, you will recreate the Zachman framework. And that's just what John's phenomenal insight was to us many, many years ago. So these frameworks, TOGAF, you have to watch some of them because some of them aren't quite as strong on the data. I forget whether ITEL or TOGAF has only 4 or 5 pages on data, so it's very light in that area. Again, we don't teach it in school, so people don't think it's an important aspect of it. And this is what, of course, we're advocating for, is a stronger emphasis in those areas. Thanks for pointing that out, though. It's good observation.
All right, and the next one is, I have my business sponsor gambling that there is no bad data, and the cost of participating in data governance, data quality, data standards, etc., is too great. How do I monetize the risk?
So again, forgive me for plugging the book, but Linda Bevelow, who's the president of the DAMA St. Louis chapter, contributed a chapter there where she was looking at exactly that situation where the owner was willing to take a gamble, the business owner was willing to take a gamble on a project. And when the project was done, they found out that only 40% of the data had actually gotten into the system. They had not converted 60% of the system. The project was on time, and she said, I think we should change the measurement there from not whether the project is on time, but whether the project has good quality data in it. And when they did that, they were able to realize $50 million in additional advantage the first year alone from this new process. I can't go into that much detail here, but again, it is in that the monetizing book that we'll talk about next month. Changing the measures, that's what we really want to do.
All right, great. And the next question is, how is Hadoop shaping up the data architecture? Have you come across any Hadoop use cases?
Yeah, I mean, again, these techniques are tremendously useful. The whole rationale for developing Hadoop was that our traditional methods were slow, and our traditional databases that we used in order to process the methods were even slower. In fact, Michael Stonebreaker came up with a 4% efficiency quote on the regular big iron databases in there. So Hadoop has a tremendous role to play in this, but you're not going to balance your checkbook with it. And you shouldn't be balancing anybody else's checkbook with it. It's not that type of a tool. It's a tool designed to give you insight and perspective into the larger piles of data that are currently unknown. When you look at Hadoop, the biggest use Hadoop is being used for right now is what we call the organizational dark data, the data that you have in your organizations that you don't know is there. It's the rot that we were talking about before. Hadoop is a great way of looking into that, as well as many other things. Again, the parallelism, the speed of the processing, the setup costs are significantly less than we have in the more traditional environments that are there.
All right, I think we can squeeze in one more. Is there a difference between a data modeler and a data analyst? I find it better if the same person does both. Thoughts?
And that may work out well for your organization. I've seen it work out very, very well. However, I've seen other analysts that are focused much more on the business, that they feel that the details that are associated with data modeling are not appropriate for them. So I think it's a culture thing that goes company by company. I've seen it work very well at some companies where they mix the roles. I've seen it work very well at other companies where they tried to mix the roles, didn't work, and then went to separating them. I think that's something you'll have to do because you're closer to the organization and you're probably better able to provide the type of guidance that they need to have. Most analysts, for example, I worked with a toy company once, they had the sales analysts. They would actually come in on Monday mornings. They hated it because this company had 4 unintegrated sales reporting systems that they expected the sales analysts to integrate. And they would spend literally Monday, Tuesday, Wednesday, and Thursday putting the data into a form, and they could spend 1 day a week analyzing it. Again, this caused immense turnover, and the way we funded the project in this case was that the cost to replace an analyst when they got mad and quit was $50,000. That just came from HR. They said $50,000 every time you turn over one of these positions. So if we could keep them for a long enough time, just reduce turnover by 10 in a year, that was $500,000 that we were able to save right there. So I don't think there's a universal answer. I think that smaller companies are more likely to blend roles. A data analyst is somebody who does, in fact, analyze data, whereas a data modeler is somebody who talks about the structure of the data and how to use it as a strategic asset in the organization. They are not incompatible skill sets, but I wouldn't try to force them to work in areas that they don't work well together.
All right, and we are able to get through all those questions. So great job. Thank you, everyone, for participating in today's event. We hope you've enjoyed it. Thanks again to Dataversity and Shannon for hosting us. Once again, you will receive today's materials within the next 2 business days. Our webinar next month will be Monetizing Data Management, so hopefully you'll be able to join us for that as well. As always, feel free to contact us if you have any questions. Thanks, everyone, and have a great day.
Thanks, Peter. Thanks, Megan. And let me just reiterate Megan's sentiments and hope everyone has a great day. Thanks for joining us. And Peter, another great webinar. And thanks to all the attendees who have really great questions and are so interactive. So thanks, everyone.
Bye all.